An aquifer is a layer of rock or sand that can absorb and hold water. Now, on our screen, we see a little bit different definition, reading a body of permeable rock which can contain or transmit groundwater. That's just another way of saying a layer of rock that has tiny holes that water could flow into, and that water under the surface we're referring to as groundwater. That groundwater is being contained in that layer. Now, Florida has a very special aquifer called the Florida Aquifer. As we've previously studied in class, we see during most of Florida's history, we know it was underwater, and things like skeletons of coral, shellfish, and fish itself piled up on the seafloor. In this million-year kind of process, we see the creation of limestone through that compaction and cementation of those sediments. That means that Florida's limestone layer, or its bedrock, is like hundreds of feet thick. So what's special about this limestone? It does have a lot of calcite in it, and it's very porous, meaning it's got those tiny little spaces. And that allows two things to happen. The limestone actually holds or contains water in it, and the water starts to dissolve the limestone, creating cracks and passages. It allows the aquifer to hold a lot of water. Now, if you look at our map here, you'll see that we're kind of in this region here, right over here. We would see we've got our Floridan aquifer where we're getting our water from. If you lived in southern Florida, you'd get your water from a different aquifer. Now here's kind of taking a look at a maybe more advanced version of the water cycle model than you've seen in the past. But if we think of precipitation as being our rainwater, we see when it hits the surface, it infiltrates into the soil, it percolates or gets filtered through rock layers, and it flows into our groundwater. Now look at this little dotted line. That's our water table, and we're saying that anything below this line is completely saturated or full of water. So notice how our groundwater actually flows into some of our rivers. I love this picture. So thinking about those passages in our Florida aquifer, I want you to think of them as like caves. And you can actually go diving into those caves. You would get to them by springs. So a lot of you probably love going swimming in the springs during the summer to cool off. Florida has one of the highest concentrations of springs in the world. And a spring is just where pressure allows water or groundwater from our aquifers to come to the surface. Now, our aquifers are great. We have some of the biggest and best aquifers in the world, right? But because our layer of soil on top of it is so thin, we do run the risk of contaminating our aquifer pretty easily. Because as you saw from that percolation or that filtering process of water going through the soil, if there's not a thick layer there, then you're going to get a higher concentration of contamination in your water. We also run the risk of pumping out or using more of our water from our aquifer than the natural process of the water cycle from rain being able to fill it up again. So we're taking out water faster than it's able to replenish itself. Now, this relates to sinkholes and our study of sinkholes because, and I want you to take a look right here where we see local groundwater withdrawals lowers pressure in aquifer. So you can imagine if you are taking a lot of water out of the aquifer much faster than it's naturally able to replenish itself, then that pressure, that natural pressure from the aquifer pushing back up on the soil above it is going to be less, and you're more likely to get that collapse of the soil above it into those caves. Now, aquifers also relate to our study of landforms because they are landforms and one of the most important landforms that we have in Florida. Remember, a landform is any natural feature that is formed by processes such as plate movement, weathering, erosion, and deposition. So in here we see weathering and erosion hand in hand as that rock is chemically eroded, weathered and eroded. All right, that's all I got to say about aquifers. I'm going to have you guys go ahead and move on to step 2.